in there. You have to put a primer on, and you have to roll it all out. But when we did a blower door test just after we put this blue skin on the whole house, it all sort of sucked in like a cellophane wrapper, and it was pretty cool, like saran wrap. Why isn't this going? Oh, sorry. So once we got the house all skinned with this blue skin, we then began the process of putting 4 inches of rigid insulation around the whole house, 2 lifts of 2 inch, all the joints staggered and taped. And then you can see on the right here, there's sort of a detail of the first course, and we used some insect screening first up against the house that you can just see hanging down. At the end, we'll wrap that back up and sort of protect the whole insulation cavity from being infiltrated by insects. And then there's a piece of bent flashing that's just sort of a bottom for all the insulation. And then, of course, we have our layers of insulation with we put the rock wool on the bottom inside to the house so to allow any kind of moisture that might accumulate down there to drain out and not damage the insulation. And here you can see all the foam going on the house. All the joints are taped, and we just go right over all the window openings. You can see then once we go over all the windows, we then cut out the windows, and they're getting ready to be removed. Here you can see on the right a detail of the insulation going around the existing door frame. Then we strap all of that insulation, all of that foam insulation, and we take out the existing windows and put in the new windows. The windows are flush, the flanges of the new windows are flush with the foil-faced insulation and taped to that plane. And I'll show you the connection on the inside. Here's what it looks like on the inside. They're sort of sticking out, if you will, as you look at it from the inside. We use these little gussets, little just pieces of plywood, to fasten onto the window frame, and then fasten those onto the framing of the house to hold them in place. And then, of course, they're foamed around the perimeter. You can also see the various tapes that we used to go from the exterior face of the foil-faced insulation through the rough frame jamb of the window opening and then seal it to the frame of the wood on the inside so that we have a continuous air infiltration barrier from the outside all the way in, and then it connects with foam to the window itself. So and it's repetitive. So there's the Henry VP100 blue skin material that comes in, and there's and then after the foam goes on, there's another taped layer, and then when the windows go on, they get taped to the foil as well. So the idea is to really seal up these openings. And we blower door tested with fog after each of these sort of layers so that we could see where there were leaks. And actually the windows performed really well. So once the strapping is up, which provides a way to secure the foam permanently to the studs of the house, also creates a space for a rain screen, so any liquid water that makes it through the siding can then just drain out. It also gives some nailing for all the casing around the windows. You can see the siding going up, and this was sort of middle of January. And then that was the end of January. And these are just some shots. We basically took a break at the end of January, and we started cleaning off roofs for about a month. And then we picked it back up. The house went through the winter pretty well. We didn't have any insulation in the attic, so it actually was a heated attic, and the snow melted pretty quickly. in the attic, we put, so for heating and cooling this house, the plan sort of evolved. We started out with keeping the existing radiators and just adding AC because that's what the homeowner wanted. Then we moved to hydro air because he decided he wanted to get rid of all of the radiators. And then we decided that we wanted this house to be solar ready. So it needed a lot of structural work on the roof to be able to withstand solar panels in the future. We didn't want to make it a move that was kind of irreversible. So our original plan was to use foam to insulate the actual roof. But in order to preserve that structural option in the future, we decided to go to cellulose on the attic floor. And we went to 2 mini splits, ducted mini splits, to serve the 4 bedrooms on the 2nd floor. Probably a little overkill, but I wanted to make sure they had good air distribution in this house. And then I enclosed them, and what you see in the bottom right is the enclosure in 4 inches of rigid insulation, which is removable. There's access panels and stuff. But the idea is that these 2 boxes, these 2 mechanical boxes and their associated ductwork are totally enclosed and are part of the interior thermal layer, thermal area. And of course, in the basement, we do our normal basement treatment, which is French drain, studded out walls about 1 inch off the foundation wall. Then we use a Delta mat, which is a plastic sheathing that has dimples in it that allow air and water to move behind it. And then we foam it with 3 inches of closed cell foam. And here's just sort of a detail of a window corner. We had one challenging area, and I'm just going to skip back to that's one. This area on the right, on the 2nd floor, where there's a shed dormer, and the dormer wall is set back from the main wall of the house. This is the south side. There's a little triangle of roof cavity that's created below that main roof, and that was a real problem to insulate and air seal, particularly air seal. And when we had the cellulose blown into the walls, a lot of cellulose dropped down, both from the side walls of that dormer as well as the east side, the face of that dormer, and filled that cavity, that triangular cavity, with cellulose. And when we tried to take it out, when we went to air seal it, because we discovered this problem had happened, and it was extremely hard to get all of that cellulose out. And when we insulated that whole area. We filled it with foam. The insulation guys assured me that there'd be no air leaks, but indeed, once we went back and fog tested it, there were lots of air leaks through there. So that's sort of the Achilles heel of the project. So in retrospect, I wish I probably would have taken off the roof in that area and insulated it from the top. This graph didn't come out as good as I planned, but it shows you generally what happened. Of course, all of our air infiltration decreased tremendously, and I have the numbers on the next slide to share with everybody. But I do have the cost numbers here, which I thought I would share. Cost numbers, I think you really have to evaluate on a project-by-project basis, because you never know what little wrinkles you're going to need to take care of as part of adding 4 inches of rigid insulation to a house. On this house, we had to probably extend the overhangs on the roof soffits on probably about 40% of the roof areas, and so that was tricky, and you end up spending a lot of time and effort in those areas. I put together a couple numbers here. Attic insulation. This is the marginal cost from going from code to R60, and those thermal enclosures that I did around the ducted mini splits, I figured out about $6.08 per square foot. That's on the 890 square feet of attic area. And rigid wall insulation in various combinations. I can't say this is super scientifically calculated, but about $16.20 per square foot on about 2260 square feet of wall area that was treated. So that's kind of the economics that I felt were relevant here.
Jonathan, that's the net of the siding.
Yeah, that doesn't include the things we're going to do anyway. So it doesn't include windows. These are not special windows. These are Energy Star 0.294U, you know, R3.4 windows. You know, they're installed very carefully, but they're casements, which actually work better than double hungs. But you know, in fog test, there was no air leakage through the windows, so I was pretty impressed with that.
How about the strapping cost? Was that paired with the siding, or was that installation?
I don't know. I didn't get that granular. Okay. I think it's with the insulation. And some of, you know, it's always hard to tell how much of the exterior trim is with your additional insulation needs and how much is just recasing windows, you know. So, I mean, I took a reasonable guess, I thought. So here are some of the numbers, different blower door tests that we did. The first initial pre-construction, we were about 3,000 CFM 50. There was a little space that had been a porch that was a porch initially in those calculations, but eventually we included that as part of the habitable area. So in I don't know, probably anything after the second one was probably included that extra square footage. So when you look at the numbers per square foot or per square foot shell, you know, it takes into account that change in square footage. But we, you know, I'm hoping we're going to get down to 1,000 CFM 50 when we can do our final blower door test in the next couple weeks. When we put the blue skin on, which wasn't perfect, we sort of had dropped by about 350 CFM, which was kind of interesting. We still had some big holes, so it wasn't a perfect test. The third test was when the insulation on the exterior was complete or fairly complete, and most of all of the windows were in. There probably were still a couple that weren't in. And you can see there we were down to about 2540. And once we did the air sealing, which included air sealing the attic and doing the basement, then the number really started to drop. You know, went down to 1425, and that's with an expanded footprint of that little porch. And then you can see where my target is 1,000. And air changes, we were started out at about 8.9, and you know, I hope to get below 3. I would have thought we could even do better, but sort of having that Achilles heel of that roof that I talked about earlier, I think is going to limit our ability. So that most recent test on April 7th, we still had some holes. We had a fireplace that was still wide open. We had, the attic hatch hadn't been put on yet, so it was kind of open to the attic. We had some utilities, dryer, vent, boiler, range hood that had still some open venting. So there's still some opportunities, I like to think, to tighten this up. So that's where we're at.
That's great, Jonathan.
Thank you.
So let's get Brian up. So we've got all the slides on the computer here. So if during the Q&A period we can come back to slides as needed.
So which group do you want first?
I don't have a slideshow.
All right, there you go.
So these are them right here. Okay. So Jonathan had a beautiful slideshow. I don't. I have a bunch of pictures. and not exactly sure the order these are in, but this is what you get when you prepare 2 hours beforehand. So this was a little bungalow actually in Lexington that is now a 2.5-story, I guess, colonial. And the client was an engineer, so he'd actually done a pretty significant amount of air sealing work himself before we ever arrived to his bungalow, because he was just, inquisitive and cold. And so it kind of hurt him, because the deep energy retrofit requires a baseline blower door test be done, and sort of the higher your number, the better, because you're actually going to be incentivized for every CFM 50 of infiltration reduction that you get.
That's through the National Grid Incentive Program.
Right. So his baseline was somewhere around 1100 CFM, which is not bad. At the most recent check-in with all our windows installed, we were at like 250. So you'll still actually get a fairly decent incentive, but we weren't able to run in there ahead of time and make a bunch of holes in the walls for him. So this is what it is. So this was essentially very close to new construction, and in fact, the program administrator kind of wasn't going to let this one in, and sort of let it slide one more time. We kept the foundation, we kept the deck of the first floor, and we were going to keep all of the walls of the first floor, but there turned out to be significant dry rot and damage to some of the sills. Given the amount of programmatic changes to windows and door openings, it was decided to just take down all but one, and that CSG would allow us to do that because we still had cavities that couldn't be inspected, which is, I guess, the definition of a DER now, sort of.
I might be able to give you a preview.
Oh, that'd be sweet.
Problem is,
yeah, I was thinking I was going to sell my old laptop and I can preview them, so.
perfect.
Okay.
And then
Oh,
you can
that's
do,
cool.
kind of do this and then.
Oh, that's awesome.
Okay.
Thank you. So let's see. I thought this was cool. This is on the way over, and not a deep energy retrofit. I wish I had a
Is that
shot.
a kennel or what?
I wish I had a slide of the deep energy retrofit we did in Belmont, because the client / developer lives next door, and they had this like 10-foot long giant, almost a foot wide icicle hanging down into the driveway next to our neat little white knit capped house that had the deep energy retrofit done on the opposite side of it. So I guess that one's next. So we actually, to try to, in the interest of saving time, we took a kind of a unconventional approach. I guess all DERs are a bit unconventional, but we actually wanted to get the windows in and get dried in so that we could start moving to mechanicals and inspections and what have you. And we didn't have our foam yet on site, and there was actually significant site work going on with water mains, gas mains, and sonotubes going in for a farmer's porch. So it was just a workaround to try to keep the timeline moving, and we actually did window bucks and the complete air seal detail as though this foam was there, and then pocketed in the foam all around it when we did get our shipment and had the site ready to put staging up.
But your zip was your air barrier, though not.
Our zip is our air barrier. So we actually we didn't cut out any of our window or door openings until we had a blower door test. At that point, we were at 168 CFM, which I think is like 0.4. So we're still pretty close to good enough for passive house. depending on whose volumetric calculation you use, shell calculation you use. A couple of tricky things were exactly how to deal with cantilevered overhangs. Some of them will be sided with like a beadboard. Others will disappear under the farmer's porch and never to be seen again. But just the same, we kind of followed the letter of the book and made sure we did them all. We might have been able to save a couple of bucks there, but so this is the basement entrance, and actually I have a better shot somewhere, but if you, I don't know if you can see too well in the slide, but it's actually just shy of the foam, so that the zip and the foam are both continuous all the way through without any thermal break or any chance for air or water infiltration. This is just a mock-up of the trim. The client wasn't sure what size. I think you kind of look at the asymmetric thing going on. So that's actually all the slides I have of the Newton project. Mike, how do I get to, I'm sorry, of the Lexington project?
So is this complete now or still in progress?
That's about where it stands. All the foam is up. So I call it a chainsaw retrofit because you don't have the rafter tails. Instead of a bird's mouth cut, we actually just do a plumb cut and then run the sheathing right up so that you can connect the roof sheathing and the wall, and then put out false work for your overhang. Then put all your heavy foam on, then your final sheathing, and that, I guess, holds it all in tension and keeps it honest up there. So we didn't actually cut any eaves off because it was a whole new second floor, but it's sort of in the spirit of that. So this project was sort of half and half. We obviously kept the existing front part of the house. There was about 5 different additions that kind of rambled off the back through eras of construction that were in really poor condition and kind of cramped. So those were demolished and this addition put on. And in this case, now we actually had to mate the chainsaw roof to the so-called chainsaw version of it on the addition. And again, all the false work. This is a little bit further along than this now. The farmer's porch actually was going to be kept, but our hand was tipped a bit this morning when it actually fell off. So it's going to be really tight now. And if you've ever taken or attended one of Ken Newhouser's workshops, he talks a lot about that connection, farmer's porch connection being a real Achilles heel. I think, Jonathan, you had kind of a similar thing going on with that space you couldn't access behind the dormer. We were going to just treat it with foam, but now we can do a really good job. Let's see if I can find. And so there's just a close-up of, but we're actually, so in the DER manual, it requires an air barrier out of fully adhered membrane. We were actually able to have them just let us do zip sheathing with all our joints taped in lieu of that, which is a cost-saving measure. I guess that's my sole contribution to making DERs more affordable this evening. But as you can see, we've got the rake prepped out with the false work I mentioned. My installer or my framer actually forgot to connect the zip sheathing to the wall sheathing, so we actually sent him up there with a roll of tape to tape the entire rake to itself and then back again to the wall again, so we wouldn't have any air leaks.
Brian, with this overhang detail, you are continuing the air barrier behind your false eaves, but not the insulation.
Correct. So, right, excellent point. This is not going to be a foam outsolation project on the walls. We're actually furring in or doing a double stud wall, two 2x4s with a 4-inch empty cavity between them. The clients didn't want any foam in the house. So this way here, oh, and also it was a historic property, so we were just a little concerned about getting caught up or bogged down with zoning, and how much does the insulation stick. As it was a bear getting through zoning and historical. So for that reason, we came in, and it was a big house, so we came in 8 inches, and we're doing double stud wall all the way around. But on the roof, it seemed to be a good approach, belt and suspenders. The foam will be outside of the envelope, and in my opinion, if there were to be any kind of air infiltration, stack effect is going to make sure that it's going that way, and there won't be any off-gassing of foam coming into the house through the roof. Try to get to some close-ups of the false work. Shot from below. Unfortunately, I don't have any interior shots, and that's about as far as this project is right now. A little further along, but this one had a really good baseline, or a really bad baseline, so a good place for them to start, of about 6,000 CFM at the outset. So the only problem with that is the interior finishes were all were a lot of them removed, so they had to accept a baseline a default baseline by the program. So if you are planning a deep energy retrofit, don't do any demolition until you get your baseline test. Quick word of advice, because they would have done fantastic had it not been for that. And to be fair, the infiltration probably would have been a lot lower if it hadn't had so much demolition done.
All right, that's great, Brian. So while Cador's queuing up there, the program that Brian refers to is the National Grid Deep Energy Retrofit Incentive Program, which pays a certain amount per square foot for following its prescribed wall, roof, and basement treatment. But you also get $1.75 per CFM reduction, which adds up pretty quickly. And so it behooves you to have a pretty bad house to begin with.
All right, so there's my contact information if you have any follow-up questions.
Or complaints.
Those can, Paul, just substitute Cador for Paul, or Paul for Cador at bigmeister.com, and then you can send them to him. So I'm going to quickly go through 3 projects that we've done over the past few years, and then talk a bit more about one that we did just this year. So this was a small single family in Framingham. That's the before picture. There it is after. We did pretty much all the, I would describe it as a very similar to what Jonathan showed you with the 4 inches of foam on the outside. We did not do the foam on the roof on this one. And then here is the graph of the primary energy over the past few years.
The drop in 2013 was when they added the PV. The part of this is primary energy, so we're multiplying the electrical usage by the primary energy factor of 3.4 or so. And it was on oil before, so the drop isn't as looking at it from a primary energy point of view. The drop isn't as abrupt as it would be if you're looking at it from a site energy point of view.
What happens between 11 and 12?
I don't know. I don't remember.
Teenager moved out.
they did do the basement a little bit after. I think we didn't contract the basement work. They got a bunch of volunteers to do it. So then here was a second one. This was a 2-family in Belmont. There it is before. There's the you can barely tell, but it's it's the same same story. 4 inches of foam. I think we did 6 inches of foam on the roof on this one. It was a chainsaw retrofit where we really removed all the overhangs, wrapped the foam, taped the foam, walls and roof completely, and then put in the new window, cut out for the new windows, just like Jonathan was describing on the walls. And then here's the primary energy. This was a new home, new owners to the home. So we don't have before, actual before data on their usage. So I think that's Mike's model, his projected model for the house based on a really high blower door number when we came into the project. We finished out the 3rd floor and also added a solar hot water system and a solar PV system. And then what Paul's in the rise over the last few years is, a bit of the initially they were going for the 1,000 home challenge, a high level of interest, watching every, kilowatt hour in the house. And, so I think they've loosened up a little bit, but still shows really good numbers. And then this was a 3-family, owner occupied in the 2nd floor, and then the other 2 units were rentals. And there it is afterwards, the spring shot. We did the foam on the walls of this one. It has a slate roof, so we went inside with the with I think closed cell spray foam. We did vent chutes created out of foam board to keep some airspace up against the back of the slate, the sheathing behind the slate, and then sprayed the 3rd floor while the 3rd floor tenant was still occupying the apartment. That's one we'll never do again. And then it's this similar data shown in a different way. We do have they have one of those combined, what's the name of that system where it's the heat produces electricity.
Pre-watt system.
Okay, so they had one of that. They put that in before we even started, so that was there. And we probably made it less efficient because it didn't have to run so much for the heat, but and then there's you can see where the after. And then this is our more recent project that I'll delve a little more into the details of. Out in Lexington, when we started the project, it wasn't in the historical district, but when I applied for the permit, it turned out it was. So that's Mass Ave up on the right, and the historic district is 200 feet, and it just clips the corner of the house. They're 200 feet away, and we're on a side street, so it was quite a setback for us. Of delays and cost the homeowner a bunch in changes to, what we had to change in design to get approved by the historical commission. These are some before shots of the boiler, as it was. There's a, or maybe the homeowner really likes his fireplace, and this is definitely one of the the difficulties. And we spent a lot of time working with Mark and the architect and the homeowner in trying to figure out how we could have a wood burning fireplace inside of a tight home. And so the solution that, we initially wanted a insert unit that would go into this. We were going to leave the chimney. It had, that's an outside wall. Well, on the first floor, there's a study behind it, but then the second and third floors are outside. We were going to leave the chimney up and just foam up to it on the outside. And we're going to put an insert with the dedicated makeup air coming to it. We couldn't find any that would fit this firebox and fit the clearance to combustibles. When you get around, they really like the wood mantle, didn't want to change that. And so the solution, we were also worried about, creating a very tight house and any kind of, with that existing chimney, if we didn't remove the chimney, and we were only able to foam up to it, anytime the house was put under the slightest negative pressure, whether it's from the exhaust hood or a dryer, we were worried about just general infiltration coming through the brick of the chimney, that being pretty much the only part of the house we weren't touching, and creating sort of a sooty smell. So what we ended up doing was we removed the entire second and third floors of the chimney, and that way we were able to complete our foam, our 2 layers of foam across that part. So that was no longer a weak link in our envelope. And we framed up a new wood frame chimney and put on those thin bricks. Basically, it goes on applied sort of like tile, except they're real brick, and they passed the historic commission. So it looks good. And then we capped it off with a sort of a real at the very top to hide the and then we ran a B vent. There was an insert into the fireplace, wood burning insert with a double wall B vent going up through that chase, the wood frame thin brick chase, and then we capped it all off with a couple rows of real brick and a bluestone, so that you didn't get all that and then see the metal B vent cap. We were still worried about the combustion air, the makeup air. The unit that we found that would actually fit within the clearances did not have dedicated combustion air to it. The solution that we ended up with was to have 2 motorized dampers linked to, so an 8-inch and a 6-inch. The 8-inch was connected up through a pressure switch to the hood vent. So every time the hood vent kicks on, an 8-inch hole opens up in the basement. And every time the dryer kicks on, a similar 6-inch hole opens up. There's a transfer grill going up to the the kitchen, so that presumably the makeup air from that hood vent, would be able to draw from that open hole. And that was all in an effort to sort of make sure that we weren't creating a backdraft situation for when he was burning wood. And then additionally, we for the heat recovery ventilator in the house, we put in a Zender, the Comfo Air 350. And if you have any real questions, you can ask John. He ended up commissioning it. But we ran a couple different modes. There's an away mode for when they're away, and then there's a normal mode, which is a balanced at 120 CFM. There's what we're sort of calling the fireplace burning mode, which is an unbalanced 140 positive coming in and 120 going out. So just to create a little bit of extra pressure to, help the fireplace. I'd say, and Mark was involved in these discussions too, but it's probably more for as the fire's dying down, because 20 CFM I think is not going to create a lot of pressure difference in that, but you know, combined with the makeup air, we felt like we had a situation where we had limited our chances of backdrafting during, you know, when he was building a fire. And you know, he's a pretty smart guy. He can, you know, monitor the situation and, you know, open a window if you know, if all these systems aren't working. The one sort of Achilles heel of that fireplace mode, or it's not, so Zender has what they call fireplace mode, which is not the positive pressure that we put into it. That fireplace mode prevents the Zender going into an all exhaust defrost mode, which would be, you know, bad when you, if that happened when you were burning in the fireplace. Instead, this other, you know, mode, which we're calling like the fireplace burning or the positive pressure, if you're in that mode and then someone's in the bathroom, and every bathroom has a boost switch. So the final mode for is party or boost, and that kicks it up to 170 for a short period of time, whatever, 10 or 20 or 60 minutes. That will override the positive pressure mode if you're running in fireplace burning mode. So, you know, the homeowner is aware of that. It's a bit of a compromise to someone who wants to have a, you know, wood burning fireplace in a very tight home.
You know, I think it should be said that this is kind of a kludge. It's a technical term, and this was also designed by committee because certain people said, well, I don't want to do that, because we did start with the idea of a makeup air fan, and there were people who objected to that. So don't try this at home. You know, and the owner is the premier system dynamicist on the planet. He probably can figure this stuff out, but all this stuff could be done with the human brain controller. Like, you don't run the range hood or the dryer when you have a fire in the fireplace, and that's going to be true in a house that's 1,000 CFM. So you don't need a passive house to backdraft a natural draft appliance, particularly a fireplace. And on the other hand, you can run a fireplace. You can run a fireplace in a very tight house if you don't depressurize it. And I guess the last thing I'll say is that if anyone here has a passive house or a near passive house that has radon, please talk to me afterwards for some ongoing research. But the idea that these systems are balanced, I think, right now is not necessarily accurate. So when he says 20 CFM, most of the people in the field right now do not have the tools to balance things to 20 CFM. So if they're coming to your house with a Testo or a chemo hot wire or something like that, you don't know if it's balanced unless you run a hose outside and you measure whether the building is pressure balanced, because flows inaccurately measured don't give you accurate pressure information. And that's been known for many years. It's not new physics. Well, if you're messing with this, then I think you would never do anything even remotely like this in a spec house. When you've got people that lived in their house for how many years, Paul? 30? How many years have they been here, John and Cindy?
About 30 years.
Yeah, so they know this house and they know what we're doing to it. And I think it's okay for them. And they didn't even need the dampers, right? They don't even need the motor dampers. They can open a window.
Right.
It's the same thing. It's a hole into the house. The idea of bringing the hole into an unoccupied basement is that the basement does the tempering. So you're not bringing a bunch of cold air right into the kitchen or where the dryer is. These days, use a heat pump dryer. Done. But there aren't heat pump range hoods. There are recirculation range hoods, but that's a different discussion. So, I mean, I think you can burn wood if that's what you really want to do, Mike will give you a lot of reasons why you shouldn't. He has many data points. But, you know, we have a wood stove in our house. It doesn't play well with the Zender because the Zender doesn't want to run its preheater, so the Zender wants to go in exhaust only. That's a whole other long story. So I would now never do a wood stove or any kind of combustion device with any ventilator that has a mode for defrost that's exhaust only. And so there are ones that don't, and so you pick those, right? So you just don't have that failure mode, because that's not a human choice failure mode. Turning my dryer on, turning my range hood on, those are human choices that I make. But when the machine at 2 in the morning decides, I'm not sure the preheater is working, I'll go into exhaust only. That isn't the choice I made, and that doesn't have good results if there's been a fire, you know, with stuff. And that's an experience. It's not theory. Kind of. So yeah, fireplaces are dumb, but a lot of us like fire, and they're going to still be in our houses. And in very tight houses with one very tight house with a fireplace, I do have a system set up that that pressurizes the house. And in a house where you don't need a lot of, like 20 CFM in my house is worth several Pascal. It's not worth several Pascal in this house. But you can set up, I've got a ventilation system in one house that pressurizes the house when they want to use the fireplace. That works fine. But you measure it. You're not measuring flows. You're measuring pressure. You're measuring whether the house is positive or negative to outside. That's important. So you're not using a flow measuring tool at all. You're just dialing the variable speed on the fan until you get, if you want 2 or 3 pascals, you get 2 or 3 pascals positive. Sorry.
Was this National Grid?
No.
Oh, okay.
They turned down, they were eligible for National Grid, but that would have required they use gas
They would have to get rid of this.
for fuel, and they wanted to go all electric. They're modeled to be zero net energy. So they gave up $20,000–$30,000 in funding so that they wouldn't have to burn gas for heat on site. So that was an interesting choice.
Did anybody talk to them about using ethanol alcohol fireplace instead? Get the flame, but not the exhaust?
They weren't. This was not an aesthetic choice, the fireplace. I mean, it's, to me,
It's not an aesthetic choice? It was.
Do you know of one of them? Well, it was,
I have one installed in my house.
Don't we have a problem at Finks, Mike?
National Grid.
That was Ken. That was
With the, let's see. How many more? Go through, let's just,
All right, we can,
3 minutes. I think that was a very, very useful
Okay.
digression there.
well,
Smart numbers.
I didn't know Mark was going to be here, so hopefully permission to. So the way we generally approach the sizing of the heating cooling systems is to model the house, guess at what blower door number we're going to achieve, and so as you can see in that bottom, the yellow bar on the bottom, we guessed at 0.1 CFM50 per square foot of shell. And so that gave us our goal of 769 for the blower door reading at CFM50. We ended up getting at 645. So, when we tested before closing out, we tested right around like 770, and we knew we were good. And then the rest of it, as you put on finishes and, get to those areas I didn't get to, we got there. So we ended up with 3 mini split systems for this house. We had a nominal 18,000 BTU ducted unit in the basement, which did the basement and first floor. We had a nominal 12,000 BTU ducted unit in the attic, which did the second and third floors. And then that one study room that was on the other side of the fireplace was really sort of a room unto its own. And we decided to put a 9,000 BTU wall-mounted unit in that room. And so Mark gave us room by room, sort of CFM flows, gave those to our HVAC installer.
They cut them in half.
Yeah, I don't know if they, so we've done a lot of talking with Mark about, so these ducted units have very low air volume and velocity, and so, duct layout is really crucial.
They have low static pressure. They
Okay.
end up with low CFM and velocity, but that's not intentional.
Well, the way we install them, they do, so. I guess they just, they moved, we don't have any after numbers yet, and really they moved in at the very end of winter, so we don't really, the house is doing well for construction guys, putting up plaster and finish, and we think everything's great, but we really need to, talk about this again next year. And then I think the only other thing, I'll wrap it up, Paul.
Yeah.
Worth talking about is we did have a high radon problem, and we had to do a bunch of moisture, management. We had to convince the city that we didn't need a dry well. So what we ended up doing was testing for the high water table. We put in an interior perimeter drain, which led to 8 tons of rock crushed stone underneath the slab in the new. We put on an addition in the back. So that became our dry well. It's sort of like, what we're calling like a close within the building. So it was not connected to any, there's no sump pump. There's no, transfer across to the footing drains or anything like that. And then we ran a 4-inch pipe up through the roof, inside the house, through the roof. And we tested at, before it was 8.6 picocuries per liter. And we tested out at 2.5 in the basement and 0.8 on the first floor at the end of the project, and that's with the HRV running. So.
But a passive stack, is that
a passive stack. We don't, we had the provision to put in a fan, but we haven't done it. We'll continue to test to make sure that those radon levels stay under control.
What's the acceptable level?
We do 4 is really actionable. 2 if you're a smoker, is sort of like what they say. And I think that's well, let's see if there's any other pictures, but I think that's all I wanted to say. There's the obligatory mountains of foam.
Guys, you just tell them to the foam.
Foam and strapping. There's the chainsaw retrofit where with the overhangs. We did. That's where the solar went. So we put down on top. I don't think anybody showed this, but we did the 4 inches of foam and then 2x4s on the flat, and then the sheathing. So we've got a ventilated space, and we've got a really good place for the PV guys to screw into. They don't like to just go into that outer 3/4 or 5/8 inch sheathing with just foam backing it up.
Just to go back, if any of you are tempted to use the panelized shingles, because they wanted shingles on the house, and with the, to do shingles with a vented space behind, it gets complicated. So we figured, brilliant. We'll continue with the vertical strapping, and we'll get those panelized cedar shingles.
Are those cement
What's that?
Are those hardy?
No, these are red cedar, but the corners are just a complete disaster.
They build it as a true square corner, but as soon as you tilt something that's truly square, and you tilt it just a few degrees, that end cut's not square anymore, and so all bets are off. I think we do these again with corner boards. We do the panels with corner boards, and actually that's what was in the design, and the Historic Commission wanted woven corners.
We should have had the Historic Commission apply the woven corner.
That part's that's the addition. That's some of the after. It was a brutal winter. There's we like putting these on the mini. We used to put the mini splits all on the ground, and now we really like these hangers. That especially after all this snow. I don't think we'll ever go down on the ground again.
So that's a great, could you go back there? So rodents are heat-seeking creatures. You know, they're looking for heat. And that thing outside, that oblong, is making heat. That's why on the inside it makes warm air. So those pipes are warm. How long do you think it takes a rodent to get from outside to inside, going through Armaflex or similar on a pipe? How many people here have seen mouse nests inside mini split cassettes? I'm the only one so far? Well, if you build them like this, you will.
How many have looked? Mark, this is Lexington. They don't have rodents in Lexington.
And we don't have insects on Martha's Vineyard, which is great. No screens. They can't afford to live there.
Question. Yeah, I think we can open it up for conversation at this point.
Are these hung on, is foam behind the wall where they're hung?
Yeah, there's foam on that, behind that is the same construction with the foam and the strapping. Yep. That strapping is unbelievably strong when you screw it off. We use those headlock screws, and you know, there's some great shots of, you know, I don't know, you used to have one, like people just are hanging off of this stuff. You know, I wouldn't be worried about that.
I think there's a picture of John Straub actually sitting on a stool that's nailed to the strapping. He's a pretty big guy.
There we go. Good.
Thanks, kid.
Thanks, Stuart. So let's open it up. Any comments, Mark?
Yeah, looks great.
Can you talk about the assembly from, I think a couple of layers, you had like a house wrap, and then you had 2 layers of foil-based and taped insulation beyond that, and in terms of like air barrier, just how does the foil-based, the multiple layers of foil-based affect that, or is that not the consequence?
We treat the outermost layer of the foam as the most, sort of like the most important air barrier, and we wrap that into the window openings, you know, and tape to the, you know, tape to the window frames, and you know, deal with it that way. But so the other layers, the Tyvek, mostly, you know, I think of it as just like that's your weather barrier, because these things take so long that you're really exposed. So you really have to have that. We tape it and we do it, you know, we do a decent job, but we don't test that air barrier with the blower door. We don't consider that our primary air barrier. That's really it's like a tarp.
Cador, can you just go through from the existing sheathing out? What is the assembly that you're using?
Yeah, so the existing sheathing, and then, you know, Tyvek, Typar, some kind of material like that, and then the 2 layers of polyiso, and then the strapping, and then the siding.
Okay, so you're using the polyiso as your air barrier and your drainage plane.
Correct. And they've got the National Grid book is really great for they've got sort of 2 paths that you can go down, where the air barrier is at the sheathing, you know, as part of that like that Tyvek layer, or as part of the outer face of the foam. And it really a lot of that depends on whether you're sort of going with outie windows or innie windows. And what I do is I take the whole book is ridiculously long. There's so many things. So what I go, like for this project, I edited that whole book down to the 60 pages or so of the details, and they'll show every, you know, wall to this to that, you know, every different connection, and I edit down to the ones we're going to use, and I go over that with the project manager and our lead sub, who's actually his crew's putting on the foam, and you know.
Mike's going to pull up the guide.
It's the Mass Save Deep Energy Retrofit Builder's Guide, maybe.
It's put together by Building Science Corporation. Steve, I don't think any of your drawings are in it?
They probably just stole them.
Sure, there's something. This is an amazing resource. Scroll down just like
Yeah, let's read the
Yeah,
legal
yeah.
Anything else?
You can go to like page like 49, 60. I think that's where the details start.
49. It does get a little interesting when you have the mix of the old and the new. We come to find out with the second project I showed, where the old board sheathing was kept and Tyvek was used as the air barrier. It had to actually mate up with the zip sheathing, which was functioning as our air barrier on the new construction. So we really defined the air barrier on the inner layer before any of the outsolation goes on.
Which page are you saying?
Right.
This range.
Yeah, anywhere past
Yeah.
49. So this is like
But what this is showing is is that it's identifying
The best
the function
section-
that each layer plays.
The best section to kind of see how the different layers play their parts is really in the window details, the window penetrations section. It's, transitions, I think, somewhere in the 90s.
We've been retesting these projects with the blower door periodically to see how well they do, and some have the numbers basically identical a year or two later. We need to continue to test. The first project that Cador showed, the blower door number went up like 150 with the second test, and we found it was because someone had serviced one of the mini splits, had completely redone the line set from the outside and had not made any attempt to fill in the hole. So, one of the things as a remodeling contractor, I love the challenge of retrofits, but I do worry about how hard we're making it to remodel houses these days in particular. There's a lot of high-performance homes that could easily get pretty screwed up by a remodeling contractor such as myself, because there's a lot of unintuitive things going on. I think the foam on the outside is somewhat more intuitive than a double stud wall filled with cellulose if you're going to put an addition on. I don't know. I do know I do not want to be the person who replaces a lot of the windows that we've put in. So I'm retiring in a few years.
I was at a house that I designed over 30 years ago in Vermont, double stud wall house, and new owner, and they were remodeling the bathroom, and the contractor had this was a house that was a very tight house, and he had all the drywall stripped off, and it's like, I don't need what's all this stuff? Why do I need air barrier here? So he pulled all the poly off. This was back in the day of goop and poly, and he was going to have a bathroom that was connected to the outdoors. Of all places.
163.
Probably 163?
Yeah.
You know what? The poly looked great. The building was designed to be second home, and it had a big solar air system in the rock bed, so it would never freeze. And all this stuff worked because there's no electronics. So the original heat exchanger, air heat exchanger worked. The fan the rock bed fan, solar fan, all that worked. The original controls work. All that stuff is there and it works because it's just line voltage, simple stuff. No touch screens, no electronic, just works. I don't think any house that I go to that I'm doing today will work in 30 years without a lot of attention between now and then. No equipment will. There isn't a thing we're putting in the house that will work in 30 years today. While you're scrolling through that, the most interesting thing I saw tonight was Jonathan's. You still here?
Yeah.
Yeah. So his first blower, his baseline blower door was 3,000 CFM 50. He covered that thing with blue steel and he got 350 CFM out of that.
Zip holes probably would have been better.
So that's an interesting thing to me, because I think that on these old houses with the board sheathing, once you actually fix the attic, so the attic can be 3,000 CFM 50 by itself, and so then you don't see any of the, you don't see the granularity of working on the walls. The attic is just a big hole. And you did 80% of your house without huge reductions because the roof wasn't done, right? I mean, when you showed us that years ago.
Oh, my,
Your house.
Yeah, my house.
So, you know, we've learned that you have to fill the really big holes. But that was sobering, all that blue skin and 350 CFM.
Yeah, not that much.
No, not that much.
Mark, have you seen Michael Blasnick's numbers on just taking ducts and getting them inside the envelope and the overall performance improvements that he's seen from that? It's astounding. That's, you know, you could spend a fraction of what you're spending on these projects and make enormous gains.
Well, it depends on how bad the existing building is.
30 years ago, the SNACNA figures on duct leakage were like 50% or something absurd. And just in terms of just general duct work. So I'm sure it's a lot tighter now, but putting it inside the envelope makes a big difference.
Putting it outdoors is a bad idea.
Yeah. John, you had a question?
Yeah, I had a question for each, just to be democratic. So, for Jonathan, what did you do for an air barrier at the attic before you started?
So we sprayed the perimeter, the exterior wall plate with closed cell foam, and then any penetration throughout the attic floor or ceiling, we also sprayed with foam. And then the access to the attic and the HVAC penetration, we encompassed in that whole enclosure system. So when you put the trap door down on that attic, you got successive layers of insulation that come down on top of each other.
For Cador, what happens when your election and clients move? Someone's gonna have to come in and explain the whole fireplace. I'm sort of curious about, you know, as you're sort of getting to the idea of, you know, these houses get sold, people move on, you come in and renovate later. You've got this fireplace condition very unique to that owner. Been there a long time already. You know, inevitably someone else is gonna. Have you talked?
Yeah.
Did you have that conversation with the owner? I guess I'm curious. Like in the.
We must have, because we had so many about that fireplace. I think we touched on every subject, every part of it. You know, yeah, maybe there needs to be a owner's manual when it gets handed off to the next generation or the next homeowner.
Or put in a gas sensor for yourself.
Yeah, or just remove it.
There's no gas in the house anymore.
Oh yeah, the gas is gone.
We do owner's manuals for all our projects.
Yeah.
The amount of people that read them is a smaller number.
Yeah. Exactly. Brian, the last you had mentioned exterior insulation on the roof on that second one, but a double stud on the interior. So how are you transitioning into that?
Good question. So the key air barrier is actually kind of already taken care of by sawing off all the eaves and making that connection airtight. So the insulative component of it, yes, it transitions from inside to out, but I think the science behind it seems to be that if you've cured the air infiltration, you've pretty much virtually eliminated the risk of moisture infiltration, condensation-related damage from air infiltration. But I guess time will tell.
With the interior, right? For the double stud.
Yeah.
Do the air barrier on the inside. Curious.
I'm pretty sure that the buyers of Cador's next house get a bottle of wine and a big box of carbon monoxide detectors.
It seems like on a lot of these projects, there's kind of an origami that goes on of multiple sheets and materials interfacing, which over time, I'm concerned about the air leakage at those connections. And Building Science Corporation, probably not listed in here, but they are embracing the fluid applied systems to create a monolithic treatment of some of those conditions. So something to look at. We have 10-year testing of projects that we're done with that. And that, you talked about ongoing blower door testing of these homes. I'd be curious to see if those numbers hold up.
How would that be applied over board sheathing? Would you have to put another layer on? Would you spray it right over board sheathing with gaps in it?
There's a detailing material that addresses joints and seams, and then a product gets rolled over that to tie everything together. But the windows, in particular, what prompted the question is, that's really where if you get a lot of buildup and multiple layers, those are opportunities for failure.
I think overall this is an old house is not going to move that much anymore.
A little bit. Wasn't there a paper that Joe's mentors, Timisk and them guys published? They went back and saw or tore apart 30, 40-year-old homes with tape, like early R2000 projects, and found virtually no difference in air leakage from original test to current test in 30 or 40 years. And that's with adhesives and membranes that were horrible compared to what was available now.
I think it's worth continuing to test. I wish more people did that periodically. I wish every practitioner went back to past projects more often and was more rigorous about really.
We just retested the Falmouth Passive House, and it was virtually same number. A year later.
Year and a half.
A year and a half.
Yes. Hey. Union of Concerned Scientists is
and a client. Not Passive House, unfortunately. It's too old a house. So just looking at my numbers, compared to what the numbers y'all were rattling off, I got work to do. But just to this issue about degradation over time, what kind of monitoring? What are you seeing as the future of monitoring? Short of doing blower door tests once a month, other than your utility bills, or normalized versions of your utility bills. Maybe our utilities will start doing that. But what are you seeing as potential options for monitoring these over the long term?
What do you want to monitor?
Well, I just want to see what's changing. The issues that y'all are talking about in terms of just leakage, and you've got great CFM figures once you're done with the renovation, and then things change over time. And maybe it's somebody coming in to do some work who leaves a hole. We bought a high efficiency heat pump for my wife's office, and the guy just left a big old hole where it came in, and in the middle of winter we finally figured that out.
These are secret advocates for rodents.
I guess. Yeah.
I think every remodeling contractor should have a blower door. I mean, we use it all the time on our projects. You test every project. It's the only way and I think that hopefully the codes and the consumers start to push for that level of accountability on the part of the people they hire to come in and change their homes. But that's Stephanie. What's your?
So I think that a pretty good low cost investment is the e-monitor or the site stage, just because it allows you to track that circuit by circuit energy use over time. And so if all of a sudden your heat pump does spike or your refrigerator spikes, you're gonna have that historical trending data, and might alert you to a problem, even if you're not monitoring moisture in your walls or something that's more granular. You might be able to sort of be alerted of a problem just from that kind of basic data.
And I think that technology, right now, that I wouldn't call that inexpensive, Stephanie. I mean,
on the scale of the projects that we're talking about, it's a $1,500 investment, and that includes 2 years of monitoring and extra circuits. So that would be a really comfortable budget number. So
There
I
are,
think it's a small incremental cost for a decent amount of information.
we have, actually, Mike and I have a client who's trying to, these e-monitors require you put a CT on every circuit you want to monitor. And what software developers are trying to do is develop one CT that you put on the main that can disaggregate all the little signals that are coming through, and so that it can figure out what's going on in the house much more easily than putting a CT on every circuit. And I have yet to meet, are there any electricians here? I have yet to meet an electrical panel that's properly labeled.
Well, so that's
So it takes about 4 hours to figure out what's going on in the panel before you can install the
Amen.
But that's what we
And that's
like about it,
infrastructure.
though, is because we explain it up front, and so it's the carrot of, like, we're going to know that, like, your dirty work is going to be exposed. And I think we get better,
I like that.
I think we get better results, though.
You're
That they know that it's going to be on this thing that the homeowner sees forever if they put, you know, the lighting on the same circuit as something else.
Yeah.
You know, that thing with the just 2 CTs on the mains, that exists.
Yeah.
There's a product which is Belgian. It's MAPI, right? And you can buy it now in this country, I think. But the reviews I mean, it's early days. The reviews aren't very good. I think that it's way easy for that thing to learn when your refrigerator kicks on, because it looks the same every time it kicks on. And the more you have things that are variable, which more and more everything we have is, makes that harder. So, and I think in the kind of buildings that we're actually interested in, where you're talking about very low loads, I mean, you know, there are times when my meter, if I had I don't know how the electronic ones work, the utility meters, but the electromechanical ones wouldn't fit, you know, because I have very little parasitic load in the house that's doing nothing, you know, phantom load. And I've done an experiment with meters, and I don't think the older ones don't even run at like 30 watts, you know, below 30 watts. They're pretty dicey because they didn't care, right? You know, if people are using 20,000 kilowatt hours, I'm not caring about the few hours that it gets really low. So, you know, the kind of houses that we're doing are actually harder to disaggregate, I think. The machinery is all more sophisticated, and it runs less. So I don't know how fast that's going to happen.
Neither.
You know, I mean, Elon Musk maybe, you know, he'll come out tomorrow.
It seemed like it was.
We're going to have to shut down soon. Let's just get one question from the back.
Yeah, I had a quick brainstorm here. For $40 on eBay, you can buy a single channel Chinese manometer and go out and get some tubing, and then go turn on some of your exhaust fans, like in the kitchen in your dryer, and get yourself a baseline. Of course, it forces you to log it on a regular basis, and you're not going to be able to calibrate your meter, but it's going to give you something to put out. What do you think, Mark?
I think you can buy vinyl tubing, 5 feet of vinyl tubing, and put it on a slope, fill it with colored water, and you don't have to calibrate it.
All right, the Boston Society of Architects gives us this space for free. In return, we try to wrap up by 8 o'clock so that they can come in and do their cleaning. So thank you all for coming. Thanks to our presenters. And see you next month, second Tuesday of the month at 6:30.
Remind me, you guys have done pressure test with the rain,